Thank you for coming to our presentation on CAD. Before we begin, this is only one of 12 presentations in our series. You can see the list of presentations in the link we will send in the chat. If you missed one of the other seminars that you wished you could have attended, don't worry, the seminar, along with all the others, are being recorded and will be posted on our YouTube channel as soon as possible.
I'm Olivia.
I'm Elise. This is our presentation on CAD. So the three main points of this presentation are: what is CAD, how we use it, weighing the pros and cons of two different softwares, as well as a demo on the basics of Fusion 360 at the end. So what is CAD? CAD is a tool used by engineers in both firstrobotics and the professional world. CAD stands for computer-aided design. It's a way to use computer programs to create, modify, and explore 2D and 3D models of physical objects online. Teams can both download models to assemble together, as well as create their own custom 3D parts from scratch. So why use it? In firstrobotics, CAD has two main benefits for the team: machining custom parts and prototyping and visualization of your ideas. For machining custom parts, we utilize CAD, where you can fully design your own parts using the software and then send those files out, STL, to different machines such as laser cutters, CNC machines, and most commonly 3D printers. It also gives you the ability to create your own custom parts from scratch, which gives you more freedom and creativity with your design. For prototyping and visualization, you can use CAD to prototype and test out ideas without ever needing to use physical parts. You can test different assemblies, movements, degrees of motion, size, how to connect things together, as well as the general layout of your robot. This means you can test parts you might want to use before buying them, as well as being able to work on your robotics outside your workspace and identify any issues your assemblies might have before you waste weeks working on an effective design. CAD can also be used for things like high-quality renderings, working mechanical drawings, and even animations in some software. So how we use CAD. Our team has been using CAD intermittently for 5 years now, with a larger focus on it last season. 3D printing. Our team uses a lot of 3D printing and 3D printed parts, not only for creating mechanical parts for our robot, but also for things such as pins for outreach events, fun number plates, as well as other cosmetics for our robot. Last season, our team printed everything from flash, push, hexagonal pixels during autonomous and robot walls to battery mounts and parts of our intake and outtake systems. You also don't need to know CAD to mess around with 3D printing. There are a lot of good websites out there that can teach you that you can download files from to print. If any of you want to reach out, our team has a lot of experience with 3D printing and 3D printers. Assembling and prototyping. This is more helpful for the beginning of a season when you're coming up with a lot of new ideas and don't have the time to test all the ones you want. As a team that shares our workspace with other teams, it was super helpful for us to test designs without needing to work in our workspace. In the beginning of the season, we were able to test super simple ideas and basic degrees of motion to understand what ideas were worth moving forward with and which ones weren't.
All right, on to my part of the presentation. So here's some examples of our robot from last season. On this, you can definitely see our 3D printed number plates. What is a little harder to see is on the inside, we have the majority of our outtake and intake mechanisms were also 3D printed ramps and just things to hold the pixels. That's our team there. You can tell that we love what we're doing a lot, and we're having a lot of fun being able to share these things with you. All right. Either way, back to like kind of the nitty-gritty of CAD. So when you want to get into CAD, you have to sort of pick a software to use, and there are hundreds of them, all with different pros and cons and user interfaces and tools. But the two most common that I ever see used in FTC are Fusion, or formerly Fusion 360, as well as Onshape. Personally, I'm a Fusion user, but I'll try to give both of them their due. All right, so just as a really quick comparison, both are free for students to use, although if you're not a student, Fusion actually is a little bit cheaper than Onshape. Fusion is cheaper and both are accessible on Chromebooks, but Onshape is definitely easier to run from a browser than Fusion is. And yeah, Fusion honestly is much more built for PC than it is for running on a browser, whereas Onshape is browser only. Fusion is more kind of an all-in-one program, so you'll get your CAD software as well as like things for CNC machining or CAE, which stands for computer-aided engineering, which is a little bit different than CAD, which essentially just means you can use that software to simulate physics and just run physical simulations and performance simulations on your parts, and things like that. So Fusion's a little bit more all-encompassing. Onshape is a lot more built for real-time collaboration. Onshape means you can have 2 or 3 people working on the same file at the same time, whereas Fusion, you can't really have that. While you can share files on Fusion, you can't have that real-time collaboration as much. Fusion has a bigger tool set generally. It also has a bigger community, which is super helpful because I've been able to find a lot more things like tutorials, as well as they have a really extensive forums and questions page, which can be super helpful for troubleshooting. But the really big upside of Onshape for us FTC kids is the FTC parts library, where essentially you can go in and pick and choose whichever GoBuilda, AndyMark, whatever robotics parts you want and just import them directly into your files. You can do this in Fusion too, but it's not as ready and waiting for you. You have to go to the websites and then download the step files and then import it. And so that's a really big plus for Onshape. Fusion is usually seen as more professional. It's more widely used in the professional community. So if you're looking for that kind of segue into a career, I'd go with Fusion. And the other 2 differences are Fusion is, you fully don't need internet to run it. It's partially, or it all comes down to where things are stored. Onshape is fully on the cloud, I think, and so you need internet all the time. So if you're someone who doesn't always have access to internet or is like on a trip or something, you can always use Fusion. Onshape's a little bit more finicky. All right, the moment we've been waiting for, CAD demo. I'm very excited. All right, let's go over to Fusion.
You need, I think.
Oh yeah, wait a minute. Sharing the screen. That's smart. Did I turn the mouse on? Oh, mouse is on. Okay. Share that. Share that. Right. Let's go over to Fusion. All right. So welcome to the Fusion workspace. We're currently in a file in our little thing, but let's go quickly over how to create a new folder and a new thing. So as you can see, I'm already in a new file. It's in the it says it's untitled. I haven't saved it or anything, but if we wanted to have a new folder, you would go up here, click that new folder button, and let's just say, let's call this CAD demo. Perfect. And now double click to get inside, and you see this little plus up at the top. Oh, we're on low battery. That's okay. Is it gonna go away? Either way, plus at the top right there, click that, full new thing, and you can just close tabs by doing that. All right, so the demo we're doing today is something that I recently did for our team, because with some of the new game manual rule changes, your number plates now also have to be your alliance marker. So we're gonna go over a super basic number plate design. All right, so the main part of CAD, 3D printing, Fusion, whatever software you're using is sketching. So sketching is how you're going to get your 2D designs and then turn them into 3D parts. So up here, you can see this. And if I hover over this or any of those tools whatsoever, you'll be able to see, it'll give you a little description below it and kind of explain what it does. So I'm gonna click on sketching, and then I'm gonna choose my sketching plane, which right now I'm just gonna click there. And so now I'm in a different workspace, as you can see from the top. So let's say that I want my number plate to be a rectangle, first of all. And usually with FTC and CAD modeling, you want to kind of play into the parts you already have. And so I know that I think it's a 3-hole C channel, or maybe 4, is 96 millimeters tall. So we're gonna go that, not 93, 96 millimeters tall. This is called dimensioning, and if I want to switch down to the bottom one, I'm just gonna press tab, and then I can play with that one. So let's make this one 312. I think that is a 12-hole C channel from GoBuilder. All right, now that we have this guy, we know that we're going to have to screw this into our robot. And so because I do a lot of CAD, I have memorized the sizing of all the holes and stuff, but the best way you can do this, where's Chrome? I lost Chrome, guys. That's okay, but you should, it doesn't really matter, but if you ever need dimensions for parts, you'll always be able to find them on websites. So if I needed to know how big a hole on a Go Build a C channel is, I can go to Go Build It and it'll show you the dimensions. So I know that it's for an M4 screw, it's going to be 4 millimeters. And so I'm going to say, let's put 2 screw holes at the corner. And you would think you'd put it at 4 millimeters, right? But for things are going to need to go, for holes that things need to go through, you want to actually add tolerance, especially if you're 3D printing, because when you 3D print, the layers expand a little bit. And so you want to maybe put that at 4.2 millimeters just to make sure it fits through. So let's do that. And so this is another really, really important tool right there, sketch dimension. So if I press dimension and then I press this, I can change that dimension to whatever I want. Because I already have a dimension on there, I don't need to do that right now. But what I am going to do is I'm going to make sure that the center point of that circle is as far as I need it from the outside. So I know that 8 is a really common number in a lot of FTC parts. So I'm going to put that 8 millimeters out that way. And then 8 millimeters out that way. So that is perfectly in that corner right there. Another thing that you can do is if I want to just have another guy right there, and I know that those 2 holes are going to have to be the same size at all times, I can set equal those 2. And so now you can see the constraint on there. They're going to be equal in size always. The constraints tab is one of the most useful tabs you can ever use. See if I wanted these always to be horizontal to each other. Boom. And now they're always going to be horizontal no matter where I move. So where's the escape button? So if I double tap that, let's change that to 12 millimeters really quick. This one's always going to move this with it. If I change this guy, is it going to work? If I double click on that dimension, which is not really working right now, but if I were to change that dimension, then the dimension for this guy would also change. And so those are super, super helpful. All right, so another thing to be aware of is construction lines. So these lines aren't useful at all for geometry. By the way, the little triangle at the top means I've hit the midpoint. But if I bring that line down, that line now doesn't affect anything. You can see because it's dotted, but I can still use it to base other geometry around. So if I wanted to mirror this guy right here, I would select that object. And because I lined this up at the midline, I can say I'm going to mirror it across this line. So now I have a little guy, a little hole right on that side, and it's always going to line up with each other. All right. So I need to move there we go. So let's finish that sketch. If you are interested in Fusion, I would suggest just going through the Create tab and just like hovering over all the things, learning about all the things. Fillets are something, or you think used really often. Offsets are super, super helpful. All of rectangle geometry, circles, which you saw me use already, those are the most common things you're going to be using, as well as, like I said, the constraints bar. But for now, we're done with that sketch. This is going to be the very base idea of what our number plate's going to look like. So next most important thing is we have to get this 2D geometry that we sketched out in just 2D planes into something 3D. So we're going to go over here to this extrude. We're going to click on that, and we'll be able to take this face right here and extrude it up as much as we want. So 57 millimeters is a little much. I think 3 is a pretty good height for things like this. So 3 or 4, I'm going to go with 4. And then boom, we have something that is actually 3D. So now we have this, but we don't have the numbers on. So we're going to go create another sketch And this time we don't have to choose one of these planes. We can just select it fully, just the plane of this. And now we are sketching on the plane of the solid and not just an arbitrary plane that they get for you in CAD. So we're going to go to the Create tab, press on text here. And text admittedly can be kind of finicky sometimes, but I want the text to be about that big. And our number is 18127, shameless plug. All right. And I know that we made this thing 96 millimeters tall, and I probably want maybe 6 millimeters of barrier on either side. So we're going to call this, what's 96 minus 12? 84 millimeters tall. And then we can come over here and see if that's a little big. That's a little bit big. So why don't we drop that down to 80? And you can see I'm just messing around in the bar right here. Is that going to fit? Yeah, we'll just go with yes. And I can grab these guys and I can move this text around to wherever I need it to be. I'm going to make sure it gets around that hole there, actually. Yeah, that's pretty good. Usually I would take this, let's dimension that at 75 just because I like nice numbers. That's not going to change the height of the text at all. That's for my own peace of mind. And then we can select these two lines to see. That's not what I want us to do. I want to get this line and this line at a certain distance, but it doesn't really matter because we're getting what we want anyway. So we're going to finish that sketch. And so now I have this text that I can select as a face and extrude out again. Let's put that at 2 millimeters because it doesn't need to be out that far. So now you can see we have a number plate that we'd be able to mount on a 12-hole C channel. And another really great thing you can do is you can come here and you can select your own physical material. So if I was 3D printing, usually I'd go over here to plastic and I would choose something like ABS, and I can just drag that over and make that ABS. And it's great because then you can go up to this tab, which is how you change workspaces. And if I wanted to run a simulation, then I could do that with the material that I'm actually going to be using. The zoom bar is actually in front of what I'm trying to do. How do I move that? Doesn't matter. I think that one's render. So rendering is something that's really fun. It essentially like detects where light should bounce off of your objects and makes them look super realistic. But just as an example of something that you would render, because number plates are not super interesting on their own, we're going to go to our bigger robotics tab. This is going to be something from last season. It might take a minute to load, but this is one of the final versions of our robot that we had. This is an example of something that you wouldn't model, but that instead you would take parts from websites and then import them in to create something interesting. Is it loading? Let's see if this computer can handle it, because big things like this, especially with metallic parts where it detects a lot of light bouncing off a lot of different areas, are really tough for a lot of software to load, but you can kind of see it there. Is it going to load or is it going to crash? These are the questions of a lifetime, people. Other than that, though, that's a pretty basic example of what Fusion is. This is one of our final versions. You can see how much it's hurting. These black pieces are all 3D printed parts that we were able to test in time before ever printing them out, just so we could see what's going to work or not. You might be asking yourself, what are all these little guys? These are all joints. So if you wanted to joint parts together, that's how you do that. You'd press this, and I could say I want to joint this little corner here to whatever I want, and you'd be able to do that. So that's an example of an assembly that we have. Other than that, there are a lot of really good tutorials on YouTube. Just look up Fusion tutorials. The first thing that comes up is probably going to be fine. Fusion has a really great community. I know Onshape, there's a few tutorials in that too. There are a ton of other software. So whatever you're using, Google is your best friend. But I think that's it.
All right, so before you go, we have sent a Google form in the chat and would appreciate it if you could fill out your contact information so we can notify you of future events. The seminar schedule has also been sent in the chat in the form of a Google Doc as well.